for you through the course of the weekend. To give you a quick rundown of how we're going to work this morning in particular, I'll spend 5 minutes talking about status and what it is. We'll then have a workshop just for status extensions, which is a really interesting new part of our release that Julian will give. And then after that, we'll split these workshops into 3 venues. So we'll have a workshop in here, we'll have a workshop going next door, and one in the Embark room, which is just behind here. Please look at the agenda and decide which workshop is most relevant to the hack that you want to do, and then go and attend that one. And you can move around from venue to venue. The whole idea of the weekend in general is really to try and encourage active participation from people. So don't just sit here passively. Think about which one is actually going to be most relevant for what you want to build this weekend, whether it's universal logins with Alex van der Sande, or whether it's a hack on Swarm with the Swarm team and Elad, who's sitting next door, or whether it's any one of the other amazing teams, the Plasma researchers, Status Extensions, the Maker team that's here, or Liquidity Network, MyBits, any of these people. It's really, really important that you figure out where it is that you can go and learn and contribute the most, and then spend the time in those workshops actually learning some stuff that you can apply through the rest of the weekend. So that's kind of the basic structure. After that, we'll have some time for you guys to find team members and figure out what it is that you're going to work on, a few more presentations from sponsors, and then hacking starts this evening and will end on Sunday morning. If you go to cryptolife.devposts.com, you'll see all of the prizes that are listed, and we'll be doing submissions through an open source GitHub repository. So if you go to github.com/status-im/cryptolife, you'll see that there's a repository set up there with very specific instructions about what you need to do in order to submit if you want to be eligible for a prize on Sunday. Again, if you have any questions, just come and find me. We'll sort it all out for you. So that's all of the admin out of the way. I thought I'd give you 5 or 6 minutes on status and what it is that we do. And in fact, I think that the best place to start is maybe with our new website, because you can see that it's a very, very sparse design. The whole idea behind this is to be functional and to have really, really great documentation, because that's how we actually build a community and a grassroots movement towards, properly decentralized everything, and not just the tech stack, but the actual organizations and the way that we group and work together as people. And I thought I'd just spend 5 minutes talking about just the language on this page, because I think it really captures what it is that we're trying to do at Status. First of all, it's all about access, right? All of this technology is about access to knowledge, resources, global trade, in general, more distributed networks that allow you to participate in value creation and which have incentives that are much more closely aligned to the participants in those networks, right? Fundamentally, everything that we're doing here is about providing access to powerful tools to people who have previously been disempowered by the way that the world is run and organized. Moreover, it's about being able to access it anywhere, so it's not good enough if it's just on your laptop or on higher-end hardware. It has to be accessible on resource-restricted devices. It has to work on low-end smartphones. It has to be accessible and usable in places like Africa and Asia and places where there's high mobile data costs. We're still a long way away from that, but that's certainly our goal. And we need a community of open source contributors and people like yourselves if we want to reach what is quite a lofty ambition. More than that, though, when we get into what Status actually is, the first 4 words there, chat, browse, and transact, kind of capture all of the actions that you can do with the app. And I want to go through each of them very, very briefly, because it was the poet Rumi who once said that if you speak a new language, the world will be a new world. And I really don't think that these are just normal words in the context of what we're actually doing. They have a whole lot more to them. So when we say chat, we mean that you're actually doing it over Whisper, which is a multicast, dark, end-to-end encrypted and peer-to-peer gossip protocol. It's not the greatest performing gossip protocol ever at the moment, but we've done an incredible amount of work on it, and there's an incredible amount that we can still do to make this the most secure mode of communication that has ever been deployed. And like moreover, it's not just about like chatting with text, right? You can actually chat with real value. So you can see that like you can natively send any token, any ETH, or in fact any crypto collectible directly through chat in status. And this is what we begin to start like thinking about conversational commerce on steroids, because you have the combination of this private messenger, right, with a public, global, and immutable ledger that transactions happen on. And when you combine those kind of technologies in the same stack, the possibilities are kind of endless. It goes much further than this, though, right? Because like, I actually have a whole talk where I sort of just fanboy Doug Engelbart and some of the guys who worked at Xerox PARC in the 60s and 70s, and the web that wasn't. And one of the key ideas from this web that wasn't was that you would have social organization of information, right? So you wouldn't just have the top-down hierarchy that we currently have online as defined by URLs, but like the way that people use and interact with information actually informs the context of how you see it, right? So links are not just one way, they actually link back and forth, and they show whether like what I'm linking to, whether like it agrees or disagrees with it. It has like contextual information caught up in the link itself. And you have these social spaces that are built around the information that we all interact with on a daily basis. You can see that we're beginning to do this in status, right? So like when you open CryptoKitties, you've got a little chat bubble down there, and that chat bubble will automatically open the CryptoKitties topic on Whisper, which is accessible to anybody, not just status clients. Anybody who's connected to the Ethereum network and running like their node with an SHH flag enabled will be able to pick up this chat. So we can start thinking about like real conversational social spaces forming behind the products and services that we offer on Web3. And that means that you can do things like community support. You can have like an active social channel directly behind the product or service it is that you're building. So when I use Gitcoin, I can just go directly from the Gitcoin interface in status to like the Gitcoin chats and figure out what's going on with the community, get help from people, try and understand what these bounties are, how to work with GitHub, what a PR is, why all of this stuff really matters. So it's not just about chatting, right? Chatting is so much more. Moreover, when we talk about transacting, right, transactions are already like the first form of interaction. They're the basis of how we form relationships as human beings, and we shouldn't need to rely on intermediaries in order to complete those, especially when it's just between one another. So we already have that. You've seen that you can send ETH and tokens in chat, but it's so much more than that, right? If you look here, this is what extensions look like, and Julian is going to demo this later, but we can install an extension which lives in a distributed file store somewhere. You just need a URL. And once you install this, it extends the capabilities of chat. So if I open a chat with someone, generally I can only like send and request, but I've got this new collectible command. I can put in the collectible for CryptoKitties and send a collectible directly through chat. Right? And again, like this is enriching the conversational experience happening behind products, so that we can actually begin to merge social conversational spaces behind the information that we interact with on a daily basis, which I think is pretty cool. So that's not it. If you go onto our website, which is status.im, if you go to status.im/fiddle, you'll see that we have a whole closure fiddle here with some preloaded screens, all of our color namespaces, our SVGs, our CSS, our icons. You can use whatever phone you want, whether it's an iPhone or an Android. You can play around with this stuff to your heart's content. Come and find me if you really want an introduction to this. And then this is something that Julian's going to talk about over the next 40 minutes. It's basically the same idea where you have like a playground to write the code that it is you're interested in and working. And then directly from here, you can click publish. It uploads it to IPFS. You can scan that QR code with status and install the extension right from there. And that really begins to get us past like needing to ship stuff through the App Store and the Play Store. We can provide a platform for people to ship decentralized and distributed code to anywhere and anyone's pockets without relying on Apple or Google, which is really, really cool. So just to bring it back to the website, that's only the first 3 words in what we're talking about. It's also really important, I think, that you realize that we are an open source community that is committed to what we do, right? Everything that we do is open source. You can always find all of our repos, all of our code. It's all out there. Please look at them, contribute, get involved in any way that you find necessary, because this is all something that we need to do together. It's certainly not about one name or one logo or even one network, right? Like, who really cares about like Ethereum or Bitcoin or Monero? What we really care about is a better web, one that is more accessible, one that is more fair, one that is more generally distributed, and one that is resistant to collusion and sort of the stranglehold of powerful people. And it's really important that that commitment translates not just to Ethereum, right, but to the whole internet. So thinking about ways in which we can organize the dissemination and curation of information in ways that are just more beneficial to the large majority of people on Earth. So that's what we're doing. We're Status. Welcome to Crypto Life. I hope you have the most amazing time here. Please participate, get involved, be creative. It's all about like radical self-expression and radical inclusion. Just like help people out, be your best self, smile a lot. We've got a lot of coffee and Red Bull. It is going to be a long weekend, but I'm really, really excited to see you. Thank you so much for coming. And if you need anything, come and find me or Johnny. So we'll have Julian up next, and then we'll break into all of the different workshops. So I encourage you, if you still need to look at the agenda, it is on the TV outside. So if you're still not sure which workshops you'll attend once Julian is done, please feel free just to pop outside, have a look, or you can find it on the website, which is hackathon.status.im. Have the most amazing weekend, people.
Great. Hello, so my name is Julian. I'm part of Status, part of the dApps and developer teams, and we're trying to just provide all kinds of tools and API for you developers to build on top of Status and just simplify your life. So this workshop is about extensions, which Andy just described a bit, so I will just go through in more details and just explain concepts, syntax, and how you can create your own extension and publish it and use it directly from Status. Because that's what my main goal, at least, is that every team here will create an extension and then use it. So it's just something that you can build on top of your dApp, interact with a smart contract. It's very small, very tiny, easy to create. So you can just spend like maybe 1 hour or even less to create it. So hopefully you will all spend some time to make sure you can have a great integration with Status. So what are extensions? So it's just a very simple way for external developers like you to integrate directly within Status and to leverage Status UX, UI, and strengths, but also API and information that you can get from Status, like contacts, or just a very simple way to access the Ethereum network from a mobile platform, and later desktop platform and others Status platform. So it's very much focused on security and privacy, because that's part of Status principles, and it's something that we really deeply feel about. So the main idea is that you cannot do anything insecure, or you cannot do anything that will leak data without user knowledge. So it had like a very strong impact on how we designed the extension model. And also it's decentralized first. So to publish an extension, you don't need to have any kind of acknowledgement. So anyone can publish an extension, because publishing is just pushing one file, one text file, on a decentralized storage layer like IPFS. No, you don't have to push your extension to a store. There is no way that Status can censor anything. So it's very similar to the web model in that regard. So it's very, very open. And also because we are trying to, extensions are about user interfaces. And creating a user interface, like a website, it's fairly complex. There are lots of tools involved, lots of technology, or even just making sure that your application reflects your information is very complex. So we try to just reuse the best pattern available and make them as simple as possible to use. So what can you do with extension? So really it depends on the feedback that we will get from you, because we want to make as much as possible things available and open from within Status, but still having in mind that we want to keep security and privacy intact. So it's really, that's also my goal here, is to just chat and interact with you, trying to understand what you would want to do with the extension. So what I will show is kind of the current state. So it's still very alpha, but I'm very interested in understanding how it could be better. So yeah, just some use cases. So currently what you can do is add extra chat commands. So from within your chat, you will be able to execute some action. And those actions, they will interact with Ethereum, or they will send messages, or they will access your local information. But the entry point is the chat, and you will execute as a user a command. But then we can think about maybe more advanced things, like eventually adding video streaming support to Status that we don't have right now. Or maybe simplifying interaction with decentralized exchanges. Or just having maybe allowing people to launch like a more complex application, but ephemeral, like something that you will scan a QR code, you will get some application, but it's very much focused on this context, the place you are. You don't want to keep this application. It's just to interact maybe because you are buying something in the street. So you want to get information and you want to hook with your wallet to send funds, but then it's just one shot. So you want this to disappear after. And yeah, again, I'm looking forward to get feedback and understand what we could do more with extension. So this diagram tries to explain what is extension compared to what we used to have in Status. So Status, essentially, as Andy said, we have a wallet, a chat, and then a web dApp browser. So right now, if you want to execute like an external application, you will just browse like a web dApp using our browser. But then it's not very integrated with Status. And you cannot do whatever you want with Status features. You cannot send a chat message, for instance, from a dApp, because we just don't expose this. And the UX is different. It does not feel like you are interacting with a mobile application. It's still web, and it's still JavaScript, and so on. So it's not native. It doesn't feel native, which is something pretty important when you are on a mobile, because you want to have a nice experience. You want to have things smooth and go and run fast. So this, you cannot really get it with a regular web application. So with extension, we directly run at the native level. So instead of having something on top of browser, on top of a regular web technologies, your extension will run directly within Status, within like the wallet, for instance, or in the case of the chat command hook, it will run directly within the native chat that we have inside Status. So essentially, if you install as a user, if you install an extension, you cannot distinguish between Status and or extension, because technically they are the same thing. They will use the same API, the same UI, the same components, so exactly the same. So yeah, because Status has a set of principles and we really believe in them, so it also influences the design of extensions and what you can do with the extension. So as I said earlier, it's very much focused on security and privacy. So to make sure that an extension is safe and will not break status, so extensions, you will not use a regular programming language to create an extension. So it's everything data-based. So which means then Status, the application, will be able to analyze your extension. And we will be able to understand what the extension is doing, what piece of information the extension is accessing, and what action the extension is performing. So we can fully understand this and then show to end user what this extension is doing. So then it's up to the user to accept and to install this extension or not. But having access to all potential things that this extension will do. And yeah, very simple, trying to make it available to anyone, not only hardcore developers. No build steps, so you just write your extension as a data file, and then you push it to IPFS, and that's it. There is no command to run, no packaging, no compilation, so it's very straightforward. So there are a number of concepts that you have to know if you want to create an extension. So I will go through them and try to explain them. So it's not a lot of concepts, but still, it's kind of important to really understand them because it will just simplify your life when you will write your extension. So when you create an extension, what you will do is you will implement some hooks. And hooks are what Status offers and expose. So what you can extend from Status. So currently we only have one hook. So it's fairly easy to understand. The only hook we have is a chat command, as I mentioned earlier. So you will be able to create a command that will be available in your chat. So that's the only hook we have right now. But this is something that Status exposed, and we decided to make this available. But then we could have other type of hook. Then when you will implement your hook, you have to decide what you want to expose and what you want to surface to the user. So to do that, you will have to manipulate three concepts: views, queries, and events. I will go through this in more details later. And then finally, so yeah, your extension will be stored on IPFS or Swarm. And finally, if you want, as an end user from within Status, if you want to load an extension, what you will do is you will access a link to the extension that you can scan from a QR code, or that you can just copy and paste from some place. So it's a universal link, so which means you can access it from outside Status. And if you try first to load this link without Status installed, it will first install Status and then install your extension. And finally, it's up to the end user to decide then if it's safe to use this extension. So you will have access to details about what is accessed, the kind of risk you are taking if you install this extension. So I will go through those concepts in a bit more details right now. So yeah, I already detailed hooks, so, but maybe just to rehearse a bit to clarify things. So hooks are what will be extended inside Status. So it's where you will be able to provide and glue your own code. And so when you create an extension, you will implement several hooks. You can have a single extension with several chat commands, for instance. And then, so yeah, the whole semantic behind this will be analyzed dynamically and at runtime by status to make sure that there is nothing weird and that we fully understand what this extension is doing. And so this is where I'm interested in feedback again. You know, if you have some other ideas about what kind of hooks we could create, you know, this is a perfect occasion to discuss that. So the view is the visual part of your extension. So it's related to HTML in some sense. So it's just a tree representation of components, and each component I will detail later maybe the syntax. So, but it's very declarative. You create your view once, so it's inspired by React. So which means you don't have to manually reconcile things. You just create your UI once, and then it's just the extension runtime will make sure that your UI is always up to date based on the information. And so where is the information coming from? There is some local state of information inside status, like the global status one, where we store contacts or transactions or any kind of information you access. And also each extension will have its own storage. And you will be able to retrieve information from IPFS or from HTTP and then store this information locally. So it's part of what the extension will do most of the time. And so the view, will directly retrieve information from this local storage of data. So it's a bit abstract for now, but then I will show example. It should clarify things. So then, how do you access this information? So within your view, your user interface, then you will declare which kind of information you want to access. Like if you want to access status contacts, you need to declare that. And you do this using the concept of a query. So a query is just some kind of API to access the local storage. So either the global status storage or your own extension storage. Right. And so the last part of this is how can I modify this local storage? How can I interact with the world within my extension? So you do this via the concept of event. So for instance, if you have a button in your extension, then you will hook an event. And this event eventually will access information from IPFS. And then once this information is retrieved, it will be stored in your local storage. And once it's stored, it can be queried, so using queries. But it's also a way to just perform like side effects. Now, if you want to upload a file using HTTP, for instance, you would do this using event. Or if you want to open a web browser, you would do this using event too. So that's kind of the only way for a user to make changes from within an extension. So actually, that's exactly the same video that Andy showed, so maybe I will skip that for now. So now we'll just detail what is the syntax to just manipulate those concepts I just described. So it's a bit more technical. That's kind of the technical part of the presentation, but it's a workshop, so hopefully you would expect a bit technical details. So, as I said, so an extension is pure data. So it's using a format called Eden. And Eden is, you can see it as some kind of a subset of JSON. So if you know JSON, you will be familiar with Eden. It's just a JSON, but with extra types. So yeah, it's just, you don't have to understand all of this right now, for sure, but just to keep in mind, so that there are different ways to encode data types, and we will leverage those different data types to simplify the syntax of extension, to make sure that it's very easy to write an extension. But then, yeah, essentially you can see like an array is encoded using square brackets, a list with parentheses, a map, which is essentially an object in the JSON world with curly brackets, and so on. But there are not so many like data types. No? But those are like those are all of them essentially. But you need to understand this to kind of navigate an extension. So now, how do you create a view? So as I said, it's kind of similar to HTML. So it's using a tree-based structure, which means it is composable. No, you can have one view and then reuse that view in another view that you are creating, because it's a very strict syntax, and it's very easy to just reuse those components. But yeah, essentially, so this is, you can see like square brackets, so it's an array. The first element of this array is the component. So in HTML world, this would be div, for instance, or text. Then the second element of this vector is properties, so it's a map. This is where you can add, provide extra information as, for instance, style. Or if you have a button, you will have a on-click, that kind of things. But so, yeah, optional, you can remove it if you don't need it. And then the last part is the recursive or composable part, because it's children. Here you will get, you can add more views. So it's the same syntax, but just one level lower. Exactly how HTML works, actually. So a concrete example. So here you have like the top element, which is a view. A view is similar to div, but just it's a bit more transparent. It's the semantic we use in the mobile world. So it's a container. There is no visual representation of a view, but it's just something that to pack together different components. And inside this view, so we don't have any properties because there is no map just after the view. But then we have some children here, and we have two text children. So those children are also views, because they are using the same syntax of vectors, first element component, and then children. And children can be a primitive type. So in the first text element, the child is a string. And the second text element, here we can see there are some properties, because we want to style the text. So you have access to a number of components from the extension syntax, and they are available in part of our documentation. So sometimes you will have to introduce new symbols or variable to access from within your user interface. So you do this using a let block. So that's this particular syntax where we're using parentheses, because this is not a view. This is not something that you will see directly visually inside your extension. It's just a syntax to introduce variables, and they are scoped inside the scope of the let block. So yeah, anyway. So why do we need this syntax? It's not only to declare variables, but it's also a way to access arguments that you could get from the whatever is calling your view. So you do this using this special keyword, properties, on the right side. So We will discuss this in more detail when we will see the concrete chat command. But it's just a way to have your extension receive external information from status. And then, because those are, most of the time, they will be maps, so objects, there is a specific way to navigate inside maps and to only access the specific information you want to access. So it's the syntax in curly brackets, name, colon name. So it's called destructuring, and it's just a way to make sure that you don't get the whole arguments, but you only get the arguments that you care about. And then you can reuse those elements from within your view. So it's a bit advanced. No, I will not spend too much time on this, but yeah, hopefully it will make more sense when we will see the full example. So now we saw how you can create user interfaces and the visual parts and the components and things like that. Now we will see how you can access information from status. So information that status expose and allows extension to manipulate. So yeah, as I said, this is done using the concept of query. And the query has this syntax, which is similar to the view syntax. So it's also based on arrays or vectors. The first argument will be a way to represent which particular information you want to access. And then the second argument, well, yeah, is a map of argument that you will provide to this query. So just to make sure that you can inform the query about specific details you care about. So this is an example of interacting with the extension local storage. So you can only manipulate queries from within let blocks. So in this let block here, you can see store get. So this is a query. And store/get is the name of this query. And this particular store/get is the query that allows to interact with local storage. And then here you provide some specific arguments, key, detailing which part of the storage you are interested with. And then on the left-hand side, we are using destructuring to only access the interesting bits of information, which is name. So here, store/get gives you back a full object or a full map, and one of the elements of this map is name. But in this example, I only care about name. So this is why I'm using this destructuring syntax. So all of this is done asynchronously, and every time there will be a change to the local storage, your user interface will be recalculated and recomputed, and to make sure it's always up to date based on the content of your data. So you only have to describe your user interface once, and then based on the data you access, it will always be up to date. So if I have like another part of my extension modifying like the local storage, like updating the key name, then automatically this part of the UI will reflect that. I don't have to do anything. So there are a number of blocks available in the view concept. So it's kind of similar to a templating language. One of those blocks is if you want to conditionally render part of your user interface. So blocks, they always use this parenthese syntax. It means that they will not show up directly visually. They are not views, they are not components per se, but they allow to interact and interfere with components. So here the syntax for if is, so if, then like the particular Boolean argument you want to check, and then nested, you will have the information that is displayed. So in this case, the text will only show up when cond is true. So in our case, it's always true. But this cond variable could come from a query, for instance. Another block that is available is the for block. So it's a way to iterate over arrays of information. So in this case, we want to have a number of text elements, one per name. So I have this array of names using the bracket syntax. And then I will specify that I want to iterate over names. And each element of names will be bound to name. And then we'll create a new text element. Now, the last concept that we need to create extension is event, or how do we interact with things? How do we interact with the world? How do I access data? How do I store local data? Or how do I communicate with a smart contract? So again, it's using a similar syntax, a vector. The first element will be the name of your event, and then optionally you can provide arguments to your event. So a concrete example here, you have a button, so it's part of your user interface, part of your view, and then one element of the properties is the onClick event. So here you will store local information using the store/put event. And in this case, I'm providing details. Now I want to store the value Julian to the name key, to the key name. Right? So this could be like a very different, separate part of your user interface that manipulates this storage. And by just manipulating this piece of data, whichever part of your application relies on this data will reflect this change dynamically without having to do anything special. And then, so eventually you will have to create local events because you need to have a way to destructure information for events too. Because if you get like a full complex object and that you want to store part of this object on IPFS, for instance, you will use destructuring to just navigate this piece of information that you want to store, identify it, and then call the event with this piece of information. So yeah, that's another syntax to allow destructuring for events. And then, so it's kind of an orthogonal concept here, but you can interpolate strings based on symbol available locally. So in this case, my text component is just using some kind of dynamic string that will be filled with the name information based on the content of this name information. Okay, so now we'll show like a concrete example of the only hook we have so far, which is chat command. So when you create a chat command as a developer, you will have to provide a number of information, just so that Status understands what your chat command is doing. So what you will have to provide is an array of parameters. So whatever piece of information you want end user to provide to your command, the scope, which is essentially in which type of chat this command will be available. So it can be in one-on-one chat or in public chat or in a very specific chat that you will identify by ID. And then, so once the user executes this command, a message will be sent. So you will have a message locally, like in your user interface, but also the people you interact with, they will receive messages. So this message, the UI from this message will be implemented inside your extension. So this is what preview and short preview allow to do. And then finally, optionally, you can provide an event. So when a user click on the command, execute the command, then an event can be triggered. So you can perform action. So you could, for instance, load data from IPFS, or you could call a smart contract. So this is what it looks like. Now you can see on the left side, so here we have the collectible command. And then user can provide separate parameters. So those are the parameters I was talking about. And then, so either a parameter will be a free form, so you can have like a string or an integer that user have to provide, or you can have a suggestion area that will be filled with visual information to help user fill this parameter. And finally, once you have all the parameters, then when you click on the blue arrow, your onSend event will be called. Okay, so now we will just take a quick look on how you will create extension and how you will make them available to end users. So we have this web-based tool called Try, and it allows to just validate the syntax of your extension very easily. And once you're ready, you can just hit publish. It will write your extension on IPFS and create a QR code that you can scan directly from within Status. Yeah, so just like another small video showing that's the result of what I will detail right now. So it's another extension. It provides a dtwitter command, and this command will interact with smart contracts. And then it will fetch information from a smart contract, then access IPFS to get more information, and finally you will get back a button inside your message, and this button allows to vote for this particular Twitter. And the vote action is actually a smart contract operation. Mm-hmm. Okay, let's see if it loads. So I have to provide some ID, then I get back this, okay, it's very quick again. Yeah, I will just pause quickly. So you have to provide an ID. Then once the command is executed, you get back a message. So you have this message locally. This message can contain arbitrary UI. You can do whatever you want inside this message. So here we just have a very simple text element and then a button. And once you click on the button, there is a call to a smart contract, which in turn will trigger the status wallet. So, and this is what we see just right after. So it's a very simple way to interact with smart contracts, and I will show more details about the syntax and the current implementation. Okay. No, I'm not done yet, sorry. Oops. So, okay, anyway. So this is the playground that you will use to create and then publish your extension. So this part is just like a very basic editor, but this editor understands the syntax of extension. So, and I will just like briefly go through this concept and explain, but just to show you on the bottom part, you will see errors if you are making like syntax mistakes. So yeah, just to show you, like every time there is something incorrect, it will turn pink, and now I show you some details about what is wrong. So it's still work in progress, so it will not catch everything, and it's not very user-friendly yet, but it will come. So the first thing you have to do when you create your extension is to define which hook you want to implement. So here you do this using this syntax. I want to implement a command. So I'm using hooks/commands just to inform status of that. And my particular command is called detweeter. Then I will provide some description as a string. No, I specify which scope it will be available. So in this case, personal chat. Oops. So right now it's just no static information detailing my extension. Yeah. Then preview, short preview. Those are views that will be used by status to display details about your message. So they are defined in this very same file. And you have to use this square bracket syntax to specify that this is a view. So view, short preview. Then every time I will click and execute my command, the load detweet event will be called. So then we will see just a little bit on top that we are creating a tweet. And finally, you define which parameters are used by your command. So in this case, there is only one whose name is ID and type is text. So it's just a free string. There is no visual suggestion here. It's just a random string. So let's see a bit more about this event on send. So every time a user will execute this command, this event will be called. And this event here is just interacting with a smart contract. So you will provide some details about this smart contract, like the address, a method you want to interact with, parameters you provide, and then the type that will be returned by this smart contract, so that status and extensions will automatically unmarshal this and make it available as a map. And finally, so you have to specify what is the next event that will get access to this information from the smart contract. So in this case, I know that I will get back a IPFS hash. So my next step, cat tweet, it's another event. This event access via destructuring the description information that is sent back by the smart contract. This is an IPFS hash. So I'm using the IPFS cat event to load the content of this IPFS file. And then I know it's a string, but I want to access a map of information from this IPFS. So again, once the file is loaded, I will send back this information to another event using onSuccess. So again, it's kind of a cascade. And this time, I will parse this file, which is JSON, and make it available in an extension-friendly way, so in a map. And finally, so again, I want to store this. Once I store this information, well, no, once I parse this information, I will store it locally using the store put event under the detweet command key or identifier. So this is done just when the user executes the command, but at the same time, a message is sent, and this message has a user interface. And this user interface is defined by preview. So this is a view named preview, so it reflects back to this preview identifier. And here we are using the view syntax I detailed. So it's just a simple text element with a button that I will use to upvote and to call the vote tweet event. So now what is interesting is you can see that this preview is accessing the detweet information from my local storage, and this is the exact same information that I got back from my IPFS file just what I was explaining just before. But then this is a static definition of my user interface. And it will automatically update once the whole smart contract, IPFS, and marshalling process is done. There is no need to coordinate those two parts. So it's very related to what you will do with you would do with React and those concepts. And so part of my message, there is a button. And if I click on this button, I will call the vote detweet event. And this event interacts with the blockchain and will call, but this time it's not a local call, it will really perform an action on the blockchain. So I have to use a send transaction and provide the relevant details. And this will trigger interaction with the status wallet. Okay, so that's essentially the whole of this detweeter extension. So there is some syntax to understand. There are some concepts, but essentially, you have pretty much everything here. Yes?
So I've got something now in that auto try thing. So which button do I need to push to actually try it somehow?
Yeah, exactly. Next step. So first, you can see that there are no errors, so you are ready to publish. So you will hit this publish button. At this step, this extension will be packaged and sent to IPFS. You get back a QR code, and this QR code can be loaded from within Status. Or you can also access a universal link. And so you have access to some kind of very small documentation in line here detailing all the components available with relevant properties, and also events and queries. Once you scanned? Well, we can discuss that afterwards, I guess. Some links, if you want to access more details. So one link to the playground, which is what I just showed. Tutorial, it's more documentation about that. The workshop, that's this presentation. And feedback, because again, I want to get new ideas, new type of hooks, what you don't understand, so everything. So it's a discuss forum. Please feel free to share and to interact with this. And that's it for me. Cool, thank you.
All right, so that moves us into the section where we break up into different workshops. The workshop that will be happening in here now is with Alex van der Sande and Marek. They're going to be doing universal logins. There is also a separate prize for the best hack that uses universal logins, sponsored by Alex. So that's quite fun, and they're a really cool thing that we encourage you to use. Next door will be Thibaut from Liquidity Network talking about off-chain payments and some really, really interesting stuff about really like making proper digital electronic peer-to-peer payment systems. And in the room behind us, in the Embark room, will be Charles from Pixura talking about collectibles, non-fungible tokens, super rare arts, all of that kind of crazy stuff. So pick your poison, and we'll get going in each room as soon as we can. Alex is next up on stage, so if you'll welcome him. Cool.
Don't go away, you like this. So, just an experiment, show of hands. Who here has developed an Ethereum app in the last 30 days? Okay? And who here has used an Ethereum app that was not the one that you were developing in the last 30 days? Okay, so that's interesting to know. So I am Alex Madasande. I want to talk about universal logins, and I'm here to talk about exactly that, like that big UX onboarding problem that we had. And it's funny, before my life in Ethereum, I was a startup. I founded a startup, was part of multiple startups, and they've all failed. So that's why you never heard of them. And we sort of believe we live by different rules, right? When you are running a startup, there are a bunch of things that you need to keep laser focus on. Things like the virality, like user onboarding, how many users are dropping out. But it seems that we don't care about that in Ethereum, as if there was something that applies to other people. And that is simply not true. And one of the things that I learned, that I used to do a lot in the startup business, was that you need to had a deep focus on this equation, which is also known as a K factor, also known as a measure of virality of your app, which is a sort of an easy equation. So the idea is that for every time a user is exposed to your app in any way, there's a chance that they might want to know more about it. There's a chance that they might want to sign up. There's a chance that they might complete the sign-up process. And it so goes on until the moment that there's a chance that they will actually publish content and expose, let's say, 30 of their friends. And what you do is that you need to multiply all those factors, like the Drake equation of crypto, and then you figure out if that number is more or less than 1. And if it's slightly more than 1, then it's great. You're going to have exponential growth. And if it's slightly less than 1, then you're screwed, because in order to acquire more users, you have to keep burning money. And how does that look like for Ethereum, for any Ethereum app? It's terrible, because what happens is that the user sees something. Oh, a CryptoKitty, I like that. What is that? Then they get into a very deep rabbit hole where at some point they are taking a selfie with their passport. And it's crazy, because no other app in the industry would ever ask you to take a selfie with your passport and wait 3 days for confirmations, and so you can buy something that you don't even understand what it is. So my point is, bad onboarding means Ethereum apps, all of them, outside of tech enthusiasts, have a viral factor of 0. Like if you have a viral factor of 0.9, that's very bad. Or it's probably something like 0.0.0, which is why we have this situation where we have more tech enthusiasts, more developers, more ICOs last year than anyone had users. And that's a very important problem, because it doesn't matter if your tech reaches people like us, like people who are fan of the technology, who are fan of decentralization. We need to reach normal people, like the average users. And those guys, those gals, those people, they don't care about Ether, about your token, or about private Cs or private keys. They don't care about KYC, and they don't understand any of that. If they're gonna buy something, they're used to have to buy a credit card. And they want a username like normal people, right? And the least thing is that they own multiple devices, and they expect to use whatever you're doing in all of them, right? If they have a browser, they have a laptop, they have an iPad, and they expect to be able to simply switch between them somehow. How do we even solve that? And we've gone through some very bad solutions, right? The first one was that in the early days, every time you downloaded a new app, you create a new Ethereum account, and it asks you to put Ether on it. And if you want to migrate to another app in another device, you need to sort of transfer that Ether. It's a terrible user experience. But then we came up with a different solution, which is you type your private key or you type your seed, which is even worse, every time you want to log in. Now, there are bad ideas, And there are ideas that are so bad that they create a whole new scam industry with Twitter bot impersonators that nearly like breaks Twitter's experience. That, like typing your private key to log in, that's a second case. It's so bad that it nearly broke Twitter. Like Elon Musk has complained about it. And now I'm seeing like this new wave of solutions. I bet like there's someone here that is working on things like this, which is a super slick proprietary login system that acts exactly as the user expects, with username, email, a password, goes through a central server. It's like the Facebook login for Ethereum. And it's a terrible idea. Like, if you're doing that, I ask you please to stop. Really, stop. Because we are not doing this whole decentralization thing so that one of you is going to just create a new Facebook out of Ethereum that has everyone's data, right? It's such a bad idea that it means that if you succeed, every one of us would have failed. So please stop doing that, because we can do better. We can do a good UI with decentralization. And I would like to show you how. This is an actual screen recording of actual code, and you can download it and clone it in the end to test it for yourself. But the idea is that it's a very simple app, right, with just asking you your username. And you type the username you want, and that's it. You select, there are multiple ENS options that you can even choose between. And once you click it, I create you a new login. And instead of asking you, I'm even giving you things. I'm giving you a token. I created a new token. I have like this 3-step security thing that every time you do something I like, I give you tokens. As simple as that. And then you're logged into the app. It was literally one click. All you need to do was type your username and you're logged into the app. And now you're ready to interact with a smart contract, right? Because that is the app, right? There's a header up there, there's a button, that button is a smart contract. You have like tokens that shows how many tokens you have. Every time you click the button, that's gonna cost you exactly one of those click tokens. And what does the button do? It's just a very simple smart contract that logs who has pushed the button. So you can see everyone who has pushed the button. Like the smart contract itself has no idea about universal logins. The smart contract itself is just a very simple thing you click. And you can see you've just interacted with a real smart contract without having to do anything. You just click there. And okay, it sounds weird, right? I mean, you didn't have to do a password or anything. How would you even like do add the secondary device if you don't have a username and password? Let's go there. So you have an iPhone, same interface. You just type your name. And in this case, because we were going to detect that that account already exists, we enable you to connect to it. And when you click connect, funny thing happens. I receive a notification on my desktop, and I can just approve you. It's simple as that. Once you click there and you approve it, your other device will be logged in. And the interesting thing is that, again, no install. That was just accessing the browser on the app. You're logged in, and it's going to show the same screen. You notice that it's this actually same address. It's the same identicon. And because you added a new device, I'm giving you a few extra tokens for extra security. It's a gamification of the thing. And then whatever I do on the device will reflect on the browser. Whatever I do on the browser reflects on the device. They are in sync, and it was sort of very simple to do it. And so far, it's very good, because suddenly you can have multiple devices. Each one is another factor of the other, like they are more secure, etc. I think that's already good enough for a lot of apps. But maybe if you have a high-value app, you might want to help push your users to do a more secure recovery thing, like a backup. So we have an option for a backup, and we've created. Everything is open source, so we just wanted to like test. Can we do like a safe backup in a very simple way? And we can. So what we're doing here is we are generating recovery codes. Those are not the backups of your keys, right? Those keys are safely stored. What I'm doing is I'm creating some extra accounts specifically for backups. And the idea is that you take them, you print them, cut them, laminate them, keep one in your house, one in your safe, one in your mother's house, the other in the bank. As long as you have access to a few of those, you will be able to back up your device. Because what happens, you set the backup code, and again, I have like this 3-step security thing that every time you do something, congratulations, you just received more backups. You completely, like the 3-step security thing you did, you added a new account, you added a new device, you made a backup, you are very, very safe. How do you now recover it? Very simple. Go to your page again, type your username, and now instead of clicking connect, click recover. And when you click recover, all you need to do is type the recovery code. And I'm even actually typing it. I could have just copy-pasted because I wanted to show you that it's quite easy. I mean, you don't need a QR code to scan something like that. There is enough entropy to be safe, but not enough that it's impossible for you. It looks like a Star Wars planet, to be honest. And there you are logged in. So what do we have here? We have a very simple login where you were able to, so you have multiple devices that ensure your safety. You have a printed paper wallet that ensures your safety. And you didn't have to do a bunch of things. So I've shown you a bunch of things. Here are the things I did not show you, right? I didn't talk about Ether. I didn't ever mention about needing Ether or gas price or gas tokens. I didn't need to show you hex strings or other things like that. You didn't have to have a password or a QR code or anything like that to go through all this very safe and very powerful experience. What you also did is incremental security as the user needs it. So the first time you log into the app, the user just wants to test it out. They just wanted to try it out. You don't need to push them to have a super safe account. As they are using it, as they are acquiring more value on the app, then you ask them, look, you should add a secondary device. Maybe you should download this app. Maybe you should do a backup. So it's incremental. More importantly than all, I just sort of tricked the user into having a multi-factor self-sovereign smart contract controlled identity, and they didn't even know it. Like, I tricked them into using multisig. So that's super important without having to explain to them what a multisig even was. So what's the magic behind this? So what is happening behind the scenes? What I'm doing is that I have multiple private keys. So every app has its own private key, right? And the user never needs to see it or back it up. You keep it on the device the most secure way you can, and you don't keep any funds on it. Each of those different private keys has no Ether or no tokens. Instead, you keep the tokens and the Ether and the Nifties and the everything on the smart contract that gives access, that is able to give access to those accounts. And the magic is something we are calling meta transactions. Is each of those keys, instead of signing a transaction, they sign a message telling the smart contract to do something, telling the smart contract, look, I want you to send this amount of Ethers or execute this smart contract. And how are those meta transactions executed? They are executed through relayers. A relayer is anyone, right? A relayer can be a server, but a relayer can be you on a desktop. As long as you have Ether and an internet connection, you can be a relayer. And what the relayer do is that they take those meta transactions, they publish them to the smart contract. So it's the relayer that is having the cost of publishing them in Ether. And then the nice part is that you can have the smart contract pay them back in tokens. So remember that every time I did something on my app, it would cost you exactly 1 token, like 1 click token. That was not part of the smart contract. That was actually the price for the relayer. So what I was doing is I was just getting all this complicated, like Ether, gas price, gas, etc., and was just making it to cost 1 token, right? Because it's my token, I created it. I can choose the price I want for it. And if you want to have backup keys, if you want to do a recovery keys, do not back up those keys, because the more you move a key, the more you add attack surface. Instead, make extra recovery keys that are always kept offline, that are kept in cold wallets. And because they are kept in cold wallets, and because it's a smart contract, you can even add some conditions in which, look, you can only do a recovery key if the other keys you have not seen the keys for a while, or if there's a time in which you have to alert the users and they can do something. So you can add extra conditions there. You can even create extra things like social backups where you have 5 trusted friends. And we are doing something very, very cool, which is called counterfactual contracts. The idea is that the moment your users log into the app, you already know, you can tell them which is their address. But you haven't necessarily deployed the contract. You can deploy the contract later, after the user has put some funds on it, after the user has proven it's an active user, not a robot. And you can deploy it in multiple networks. So what you can do is that you can deploy it very cheaply in Rinkerby, on your DApp chain, in a POA chain. And then only when the user wants to, let's say, take their tokens out of your app and do something, then you can deploy it on the main chain, and they will have the same they will keep the same address, which is super important. And another thing we are doing is that not every key has the same privileges. You can have different privileges for every key. So maybe that key that you just added on the browser, because the browser is not such a safe place, maybe it has less privileges. Maybe a key that is on a game has no privileges at all. It just can interact with the game. Maybe the key on your more solid wallet has all the privileges it needs. So what does this mean? It's better for users and it's better for the apps, because the current state we have is that the more you install Ethereum apps, like the less secure you are, because you're moving Ether around multiple places, or you're sharing your private key in multiple servers. In this situation, in this architecture, the more apps you have, the more second and third and fourth authentication tokens you own. And we can have cross-compatible usernames. So whenever you log into Status can create you a username, then you can use the same username then to go to the to Gnosis or the Dutch X auctions or to a decentralized exchange. Those can be so it's a more interesting user experience. And users don't need Ether, and because they don't need Ether, you can come up with different business models. Maybe they need your token, maybe they need to buy your token somehow, or maybe they don't need even any token, and you have some sort of subscription model where you pay by credit card, like $5 every month. That's up to every app, because the user themselves, they don't need Ether. So our goal here is not just to build the best onboarding for Ethereum. I think it's really to build the best onboarding experience anywhere on the web. And I believe you can, because not only you didn't have passwords or QR codes or have to remember any of those, you're also in control of your own identity. Everything we did here, the user is in control of their identity, of their information, of their in-game assets. And that's not something you see elsewhere on the web. So I encourage you to go to that address, clone it, fork it, test it out for yourself. You're gonna find it's very useful. And I would like to thank the Ethereum Community Fund. They gave a generous grant of $25,000. With F-Prize then was able to match with a bounty and the support for Ethereum Foundation. Otherwise, we wouldn't be able to do this work. And thank you, and I would like to call Marek on stage to do a very quick demo on things you can do with universal logins. Thank you.
One, two. Okay. great to be here. Alex showed a couple of things how it could work. Oh, it's not showing up, I think. It's showing up. So I need to do something. Is there anyone in charge? There is no image, there's no presentation. Ah, yes. Woo. Good. So Alex showed how it could work. I want to show you a little bit more from the development side, how, what does it mean to build it. And in particular, together with Alex, and thanks to different foundations, we are working for almost 3 months now on building SDK for creating applications using these patterns, these design patterns for creating and managing user identity, funds, login, and so on. So it's super easy to create an SDK. You just initialize it with address of relayer, and you just initialize it with Web3 provider, and you have SDK you can play with. So if you want to create an identity, if you want to create a contract that represents you on the blockchain, that enables all these different functionalities, all you have to do is called SDK create and the name you would like to have. The relayer have to support the domain ethereum.eth, and then as long as the let's say Alex, the login part, the label part is free, you just created your identity. It returns a private key that you should store on this and only this device, and it returns identity address, which is basically where the ENS domain is pointing to. So the contract has been deployed, the ENS has been registered, and you can start playing. Once you have that, you can execute message, and again, it's pretty simple. You just call SDK execute, you put the address of identity or ENS name, you put the message, which basically is very similar to a message you would pass to an Ethereum transaction, and you have a private key that is used to sign the transaction. So from should be always the identity address, and you can also say what is the gas price and gas limit and the token you would like to pay for the transaction with. So you don't need to pay with Ether. You don't need to have any funds on your private key. Everything is being paid by the contract. That's already here. You can connect from the other device just by calling connect, identity address, and some meta information about who am I. Once you are confirmed from the other device that you are allowed to connect with another private key, so here's another private key to be stored on another device, you can subscribe to a message and you're already ready to go further and use another device with this particular smart contract. So before I go further, I just want to say that we've spend a lot of time building the proper development environment so that it's super easy to develop those applications. So to give you an idea, here is a script. This script runs an example application. So what this script already does for you is it, is that the right script? Sorry, that's not the right script. That's the right script, yeah. So what the script does, it creates a Ganesh environment, it deploys mock ENS environment, it deploys a bunch of contracts for testing, clicker, it launches a relayer, and basically at the end it launches the example application. So bam, you're ready to code, and then here's the application. Let me show you. That's exactly the application you have seen on the Alex presentation. I can create an identity. It's all working on local Ganesh. I can play with it. And this application is pretty complicated, so we created a very simple boilerplate that you can run simply from a different console. And when you do, let's give it a moment. So that's going to be an application that has basically one React component that is around 100 lines of code. Just to give you something you can start with, we need to take the proper address. Got it. I think I got it. Okay. I will increase the font size. Good. And so I created here an identity called Marek, and I'm going to connect now to it. So I click connect. A nice spinner could be very useful here. I can go here, I can accept request, and I'm already connected. I can play with identities and messages. So, thank you. So that's basically it. I don't have a shortener address, but I guess it's the same address. So if you like it, we would love to help you hacking around. We would love your feedback. It's a very fresh work. So I think there's a lot of feedback for us to listen to. And yeah, since I have a moment, I would like to thank George and Kyle here. George and Kyle. So we have two open source contributors that already put a number of pull requests. So that's also great. And we would love to see how you build applications based on it, and we would love to see your contributions as well. Thank you very much. I think we have time for questions.
Okay, so yeah, we have a few minutes for questions if anyone wants to ask something. Okay, Griff. Okay, so how do we deal with attacks if one of your keys is leaked? I think one of the important things is that we are trying to also come up with a new standard for key authorizations, where each key has an external contract that sets limits on what sort of things they can do. And I think it's important that we come up with things like maybe a key can only add one new key per day and things like that. That can be enabled by those third-party contracts. One of the attack vectors that I like, that people in the community found was that, like, if you have a Chrome extension, it can read everything in all websites, including your passwords, including like things that are kept on private. On like your local storage. There is no encrypted storage in the Chrome browser. So in order to prevent that, we will probably need something where each key has a lot of limitations, and you have maybe a server that has another more stronger key, or maybe you need to install a third-party app that has stronger keys. But the idea is that there is no one universal login server, right? Anyone who's running an app can create their own servers with their own privacy things, with their own privacy methods. And so if one of those is compromised, and ideally, no private keys should be stored in the server. But if a server is compromised and starts collecting their private keys, like the others would be able to detect it and kick that key out.
If I may add, I think we still need to figure out the best key management practices. There is a bunch of ideas running around recovery. There's a bunch of ideas running around about different type of keys, what keys, multiple signatures, smaller amounts, less keys, bigger amounts, bigger keys. But the truth is nobody ever did it successfully and have a user coverage big enough to like see how secure are really those things in practical life. So that's, I think, definitely something that we would love to work, and we would love to see you working on.
There's a question there. Yeah. So it's coming back to like, don't do a Facebook Connect question. And I think, here's what I think. I'm okay with having a system in which you trust a third party in the beginning for your security. As long as, number one, that third party should not, like, your private information and probably like a lot of your private keys should not be in the hands of the third party, so it reduces like the damage that the third party can do if it's hacked. And the second thing is that the user should not only have an option available, but they should even be encouraged to, at some point, get rid of that third party, right? So what I think we have is a system where in the beginning, when you're small, when you're fragile, you have a lot of centralized recovery options. But at some point, the more like funds you have, the more things you have, you either push that option away, remove them if you want, or even add further options to increase the limitations, or maybe make so that central server will only be one factor of many. I think as long as you can, and you're encouraged to reduce the power of that one third party, I'm okay with that. My problem is I'm seeing a lot of people that we're not doing this whole meta transaction thing, and instead we're just doing a system in which, look, we keep your private key, but it's very safely encrypted and stored, so trusted. And I think that's a bad approach. So right now, it's as private as anything on the blockchain. So you can follow an address and see it doing a lot of things. But in theory, and I think because the signing, one of the privacy leaks in Ethereum, and I think one of the reasons that it's hard to do a private coin in Ethereum is that you are always like, someone who needs to pay the gas. And if the person who owns the coins and is moving the coins is paying the gas, then that's a privacy leak. One of the things you could do with something like that is that you could have because we are now separating who pays the gas and who is signing the messages, I think it's probably easier to build an even more safer and private, let's say, coin, in which instead of on the meta transaction, instead of just proving that you own, you can have a key. That key is not stored on the blockchain directly. It can be encrypted. It can be inside a Merkle root. And what you do is you prove to the coin that you own one of those keys, and then the coin can move that from one address to the other, and that can be all done without having to store that information on chain. So the short answer is as non-private as any blockchain application now, but I think it builds an architecture that will make it easier to make more private things. Yep. David. So we have like a Telegram group that we call like the Meta Cartel, with a bunch of people that are joining together, that are trying to figure out all the economics of the relayer tokens. So the idea is that you can accept any token, right? So the thing you can do is that your relayer can choose which tokens they accept. So if you're doing something with a worthless token, maybe there will only be like one app that accepts a token, and that app runs their own relayer. Or maybe what you can do instead of you can instead use DAI, and then any relayer would accept DAI because it's a common thing. Or the relayers themselves could check a decentralized exchange to see the price. So that sort of depends on the relayer. Like the relayer has the option to decide either they want to accept a token or not. They have the option to accept how much they are willing to be paid for each token. So it depends on that economics. Oh, it depends, right? the user is paying because the tokens are coming outside the account of the users. But what we did in the beginning is that we gave them a few tokens. So the app developer should try to see it as a publicity where they can just give out tokens. And it's better to give out tokens than to give them Ether because it's your token to have more of them, and you can control what the user does with their tokens. And the moment that you give them tokens, then they are the ones paying with the tokens you just gave it to them.
I think there was a question over there. Is there still a question over there?
Okay.
There is a question over there.
So the idea is that a user has a smart contract. The identity of the user is one smart contract. How many other smart contracts you use, that depends on the user. But in a sense, you only need one smart contract. And in my opinion, you should have one key per application per device. So if you have 3 Ethereum apps on your iPhone, you should have 3 different keys at least. Well, it depends on the type of problem that you're thinking. If relayers decide simply to stop, then that's a problem, but it's a little bit like a gaming server deciding to shut down. The difference there is that if a gaming server decides to shut down, the app is gone, there's no way any user can do that. But in this scenario, if other users care about that particular app, they can run on their own relayer. If there is a problem in which nobody can run new relayers, then that would be a very big problem. Like that would be a very big problem, but that would be sort of, well, but I don't see that scenario happening, and it's the sort of thing that all the relayers together should try to come up.
One more question? Or?
I think we're done with questions then.
Okay, so just to emphasize, you can always set up your own relayer and process all your funds, right? So there is no risk of locking other than, well, it's fairly complicated to set up a relayer.
Also, to finalize, what we are proposing is a common architecture. Like all the codes are open source, all the standards are up to discussions, like the code of the logic of the relayers, everything is up to discussion, and this is what we are doing in this blockchain whole week. Thank you.
Thank you.
Okay, so that moves us swiftly into the next session, which is a real humdinger. I feel sorry for you guys having to pick here. What's going to be going on in this room next is the Embark demo with Pascal and Eric. This Embark is the future of frameworks on Ethereum. The work that's been going on in this team is genuinely insane. I strongly encourage sticking around to hear what it is so that you can figure out what you can build with Embark this weekend. Across the hall, there's a presentation from Yuso of Streamer. He's going to be talking about Internet of Things and Ethereum and cold chain monitoring. And then in the Embark room is going to be Jesse from Bloom, and he's talking global payment systems and APIs. Bloom is using the Whisper protocol to gossip all sorts of identity information. They also just announced a really big deal with a very well-known company and credit card provider, which I'll let him tell you about. So, Internet of Things, payments, Embark, and the future of frameworks on Ethereum. So take 1 minute to find yourself, and we'll get going. Guys. No, don't pay attention to that. I'll walk past when you have like 10 minutes. Yeah, all right, that's a good 10-minute warning.
With big sign.
I really want like boxing girls.
Yeah,
That's
yeah,
really
yeah.
like come across in a bikini and stuff.
Good to meet you in person, man. Say hey, first of all. Good to meet you.
there's a lot of people here. So there's a lot of people here. Maybe we need to sacrifice a goat to the demo gods or something. No, that's not what I want. What is it? This is a split screen. It's not a.
But it's mirror, you know, so you should see it.
Yeah,
What if you move this, or is it full screen?
Yeah, it's full screen. It's full screen. You see that?
The full screen stuff. So usually only.
Or is that? Can you actually see it? Oh, I can't even actually scroll to it. Hold on.
What are you trying to do? You can go arrangement,
Yeah, that's what.
but we wanted a mirror, no?
Do we?
Yeah, sure, because we want, if I type you, we want it to see.
No, yeah, fair point. Well, then. It's tiny.
And we just, can we change the resolution here? So
There we go.
it's much better.
Sweet.
Just cat picture and a picture of yourself there. Keep in mind.
No, that's fine. So.
Do we have to be in full screen mode, or can we just not be in full screen?
Well, yeah, there's
Like,
a.
I mean, the full screen, but not the full screen mode. That would be great.
Yeah, just one second. I'm just gonna do that here.
Yeah.
And then, sorry.
No worries.
Okay, finally. What's up, everyone? How's it going? See some familiar faces out there. That's good. So my name's Eric. I'm from the Embark team. This is Pascal as well. We're gonna present decentralized Twitter using Embark. You probably might have already seen this, but hopefully today we're gonna show you some features using Embark 3.2. Thank you. So, who here has built a dApp? Got some guys? Cool. Who here has built a dApp using Embark? Oh, yes. Oh. Barry, I know you've done some. What's your name? Yes, that Bruno guy. Thank you, thank you. All right. Anybody else using Embark? No? I needed someone else that's not Barry that give me a name here. Throw me out a name. What's your name? Bo. Perfect. All right, Bo. You get a t-shirt, Bo. That's good. I'm gonna pick on you though. Sorry. Sorry. All right, so what are we gonna build today? We're gonna build decentralized Twitter, right? This is what you're looking at. So I've got two screens up here. One is they're basically exactly the same. First thing I want us to notice is that we've got 3 accounts. We only have 45 minutes, so we have to go really fast. I'm gonna talk fast. Pascal is gonna talk fast, and it's gonna be really quick. All right, so this is what we're building. First thing you're gonna see here is, hang on a sec. Before we do this, okay, well, it doesn't really matter. First thing you're gonna see here is we've got 3 accounts. So these are accounts that the node controls, right? And this is sort of like a MetaMask replacement. Embark has set these up for us in a config file. So it's really easy for us to set up accounts, use them quickly without having to worry about MetaMask, okay? So first thing we're gonna do is create an account. As you can see, I've already created 2 accounts. And Bo, I was gonna use your name here, but I've already done this because I was practicing for this talk. But if you look here, we've got 3 accounts. One on the left is me. One on the right is this guy named Chris, and he likes ponies, right? And so there's an accurate picture here of him. So if you imagine that the account that you select is your user, so what we do in decentralized Twitter is we map a user to an address, and then from there we can start tweeting. So if you look on the left, I'm logged in as me, and on the right, this guy named Chris is logged in. So Chris wants to view my tweets, so Chris is going to go here, check out my tweets. You can see here that I've already tweeted about how Chris likes ponies, right? So The other thing I'm going to say as a user, I'm going to say, oh, I'd like to tweet something. Bo is pretty sweet. I bet he likes ponies too. All right. And then, boom, you see it here. So these are all tweets that are happening inside of the contract. Those are all posted to the contract. It's all happening in real time via events, contract events. It's a very simple dApp. It looks simple on the outside, but underneath the hood, there's actually a lot of moving parts. So this is what we're going to be building today. I'm going to move this out of my way a little bit. So this is what we're going to be building today. Okay, so first things first. If you guys don't know what Embark is a simple and powerful framework to help us developers build dApps. And not just any dApps, but like fully, truly decentralized dApps. So we can build contracts with it and deploy them out automatically. We can interact with decentralized services like IPFS, Swarm, so storage, communications like Whisper. We can unit test our contracts, and we can webpack out our site and push it out. And also, it'll watch all of our files, all of our contracts, and redeploy, recompile, redistribute everything for us. So we're going to build this guy using Embark, but also we're going to be using some of the cool features of Embark 3.2. So first thing that I want to do is show you one of the cool features of Embark 3.2 is actually Embark Docker. So we have a Docker image. So why do we want a Docker image? It's pretty convenient because, first of all, if we don't want to set up all the prerequisites for all of the decentralized services, such as like installing Geth or Parity or IPFS, Swarm, all that stuff, we just want to have a container we can get up and running. Bang, we can do it with Embark Docker. Also, if we have any CI or CD stuff that we want to interact with or script Docker with, we can do that, which is pretty convenient. If we want to switch Embark versions, since I know that like we move kind of quickly, sometimes switching versions can help. We can do that with Embark Docker. So side note, everything we're doing here today is in a repo, and we have instructions for everything. We have commits labeled for everything, for every step that we're going to do. So I will quickly show you that repo here. So it's this Embark dTwitter workshop. And if you click on instructions, notice that we are in the start branch. So if you click on instructions, there's a step for everything we're going to do. Okay, so I've just gone through the overview. I don't have to click on it. Next, we're going to be doing this Embark Docker install. So just really quickly, it's only 2 lines. How do I install Docker for Embark Docker to get our image? First thing I want to do is specify a tag. That's going to tell me which image I want to get down. This is for Embark 3.2.3, so that's the image tag I want. Nice and easy. And then we're going to get access to this run Embark command. Okay, so we're going to source in run Embark. All that does really is forward any of our Embark commands to the container. Right? So instead of normally we'd run Embark blah, like Embark run, but in this case, we have access to run_Embark and forwarding all those commands to the actual container. So I can do, for example, run_Embark version. This will actually go into the container, tell me which version of Embark we're using inside the container, and you can see it's 3.2.3, which is what we expect. Sweet. Next thing we're going to do is create a new dApp. So that's usually using Embark new, right? So first thing we want to do, we want to say, all right, create a new dTwitter dApp. That will instantiate, that'll basically init a dApp for us. Embark will init it for us. But what we're going to do is we're going to add in another feature in 3.2. It's called the template feature. So this is like kind of like a shortcut. If you wanted to install like a TypeScript template or a Vue.js template, basically all the templates listed here on our site. It's pretty quick and easy. You can just say Embark new, app name, -- template, TypeScript, something like that. It's really quick and easy. But there's another cool feature that we can do. We can actually take a URL from GitHub and use that as our template. So what this is going to do is it's going to essentially clone that site into our dApp, and then Embark will initialize it as a dApp. And for this particular workshop, we're using 2 branches. One is the start branch, and the other one is the solutions branch. Start branch is where we're starting. It basically contains everything you saw in that dApp that we first showed, with some of the code redacted that we're going to fill in today. So we want to start in the start branch. We run that, and it's going to basically install a template. It's downloading it, It's going to install all of our dependencies for us, and it takes a second. Or two. While that's loading, put some elevator music on. Who wants a t-shirt? Oh, we got some, all right, we got 4 or 5. Okay, this is good, Okay, I'll hook you up afterwards, And come check out the Embark room as well down here at the end of the hallway. We've got a lot of t-shirts there too. So, how was your trip in? Sorry.
Yeah. Oh, are those long sleeves?
What? Oh, yeah, the t-shirts. I'm like, what? With a little hood too.
Actually, yes. Those are long sleeves with hoodies. Actually, yeah. I've never seen this. I think we're done.
Stylish. Oh, we're done. We're ready. Okay, sweet. Okay, so let's check out what we actually have here. So it created a directory for us. It needed our DApp. Let's check it out. So first thing I'm going to do is load up our favorite IDE. And this is our solution here. So basically, what we're looking at is a sort of a standard solution for an Embark DApp. Just very quickly, I'm going to briefly go over it. At the root, we've got Embark JSON. It's sort of like an overview config. It tells us where our contracts sit, where we want our build directory from Webpack, where we want our config files, and also there's some instructions for Webpack to actually say what are our source files and where do I want our outputs to go. Then moving on to the actual folder structure, we have our app folder. That's basically got all of our DApp assets. Nothing crazy there, JavaScript, HTML, CSS. And then config, so all the config files sit here. Very quickly, we'll tell you briefly about them. We have blockchain JS. That's a config file that essentially configures how we're going to run our geth node or our parity node. It takes all of these configuration options and then forwards them off and kind of builds a geth command for us or a parity command for us, which Embark actually will run as a child process. So all of this kind of happens under the hood. One thing to note here, the number of accounts here. So this is sort of like, Embark will create some accounts for us. If you remember at the very beginning when I showed you the little drop down, so the number of accounts listed here, so that drop down was actually generated because we created 3 accounts on our node and it populated it with 5 ether and funded the accounts. So nice and easy. All right, so communication, this configures Whisper. We're not using that today, but it's pretty cool. Contracts, this is like, where do I want to deploy my contracts to, which node, and how do I want to interact with them on the DApp, in our DApp. Also, like when we're deploying our contracts, we can specify constructor arguments. Next thing, name system, ENS. 3.2 has ENS support. This is how we configure it. I'm not using that today as well, unless at the end if there's time, but I have a feeling there won't be. So storage, so IPFS Swarm. How do we upload? If we want to actually host our DApp, we can upload it to IPFS or Swarm. This is basically configured here. And how do we want to interact with IPFS or Swarm inside of our DApp? It's configured there. And then web server, when we're actually viewing our built website. So it's config, contracts. There's only one contract for our decentralized Twitter. And then our test spec for that contract. So all of our unit tests are going to sit there and test. So, all right, moving on. We're actually going to code this thing. But first, so we now know that inside the Docker container, it actually created a file structure for us, right? We have our DApp fleshed out because the Docker container was mounted. So just in the interest of time, I'm just going to switch over to a local Embark install. So I'm not going to be using the Docker container anymore. I'm going to be using a local Embark install. So it's actually globally installed on my machine. You can install Embark globally. You can install it locally to your DApp. You can use Embark Docker. But today we're just going to use a globally installed Embark. It's just a little bit easier. It's to understand, especially for you guys. Don't want you to think, okay, are we running this in the container? Is it in Embark? Or what's happening? So I'm going to be running this stuff here. So I'm just going to go to the folder that we created using Embark Docker. So you see we have files here, right? And so all I have to do here to run this is Embark run. Now remember, we're running a DApp that is just a skeleton DApp. Notice it basically kicks off a browser for us. Shows us that it's building. We've got a dashboard that kind of spins up as well. So a really quick tour of this stuff. looking at the top right, we've got an environment. So Embark lets us set up environments. We have development, we have testnet, we have production, mainnet, private net, all that kind of stuff. So depending on where you want to deploy things to, we can set up environments for that. So right now we're in development. Status is pretty self-explanatory. This is pretty key here. Available services tells us what we're running, what Embark has spun up for us. Obviously, we're on Embark 3.2.3. We have a get node spun up, what version it's on. We have IPFS is up and running. Those are all green. It means that they're running. Swarm is red. Wah-wah. It basically means we have a configuration problem and Swarm didn't work. But it's good to know that that was meant to start, and it's not, so it's red. Also, we have web server. It's running at localhost 8000, and Whisper is good to go. Top left, we have our contracts. So any contract we have inside of our DApp should be listed there if they're deployed and what address they're deployed to. And then obviously down here are the logs. So you see here, there's some red stuff there. That means, I don't know if you can see that really, but basically it was telling us, complaining about the Swarm config, which is why it's red. There are some, so you can see here, it's kind of like, these are the logs for Embark bootstrapping our DApp. It's basically trying to detect if there's a get node running. If it's not, it's spinning up another one, trying to detect if IPFS is running. Otherwise, it's spinning up a node for that. And then goes through all of those processes. Then it compiles our contracts, gives us a whole bunch of warnings here about our contracts. Those are going to go away soon. It's because we're basically on the start branch. We've got a redacted contract, and Pascal is going to help us out with that. And then it basically webpacks up our site and tells us that it's ready to go. So if you look back again at our website on localhost 8000, it's ready to go. Now this is sort of, remember, this is the skeleton site. There's a lot of stuff missing, and now we're going to start building it. Cool?
Cool. All right, I'm going to take over the mic here. Fortunately, we don't have two of them, so we have to swap places. There was a lot of stuff, right? Right? Embark takes care.
I can talk fast.
Yeah.
I should be a used car salesman, I think.
So Embark really takes care of a lot of different things, as you could see. So it's really not just about compiling smart contracts. It actually goes far beyond that, deploying your app on IPFS and doing things like that. Let's actually see how we can build this Twitter app ourselves. And as Eric already said, we have the skeleton app here. This is already running. Some things are working, some things are not working so much, so we can click on an account here. But if I would actually try to go ahead and create our first Twitter user, this would not work, because the whole functionality is not there yet. And we start doing this now. Let me move this thing. By actually, yeah, first taking a look at our contract. Let's see. This is, by the way, for me, more or less the first time using VS Code, so that's going to be interesting. Right, so in our contracts folder, we have this dtwitter contract file, which is already prepared for us. And it already does some things. It doesn't really work yet, but it has like the minimal things that we need to get things going, so we can focus on the most important stuff here for this workshop. Right, so we can see that our contract has a user struct. This is basically a representation of the Twitter users that we can create. So every time we go in the browser here, we create a user. This is when we create a user from that struct, basically from that representation there. And then we have like two mappings going on here. We have users and we have owners. The reason we have that is because we want to be able to figure out like what users do we have. Like we map a hash to a user struct object, and also at the same time we want to know which owners are owning a particular user, right? So that's why we have a mapping from an address to a hash, which is the byte 32 there, and that hash maps to a user struct. So those are the two mappings that we have right there. Another thing that we have is an event for a new tweet. That's a cool thing that we can do in smart contracts. Obviously, probably most of you know that. You can like emit an event, and other components, other systems can basically subscribe to these events and get notified when anything happened. In our case, this is what we want to use to notify the outside world that a new tweet has been sent. And then we have create account. This is the function that's going to create an account. There's a little bit of stuff going on here. Misses some functionality. We'll build that in a second. One thing we want to double check is that when this function is being called, we want to make sure that the username is not empty, right? Because we don't want people to create a user that doesn't have an actual username. So that's a requirement here. We also make sure that we create a hash from the username so that we don't actually store the real username data on the contract, because the data is public. And then we double check whether that user hasn't been created already and whether that owner hasn't already created like a user for that. We have a method for editing an account. This is simply for us updating the description of a user or a profile picture, which is what we can do as well. And the cool thing here is that we'll actually deploy our profile pictures to IPFS using Embark, which is pretty cool, I think. We have a method to check whether a user exists. Also here, the method body is missing. We'll implement that in a second. And then last but not least, we have the method to perform an actual tweet. So I'm going to go ahead and implement the first method here, create account, it is. And just work my way through. And once we're done with that, we'll actually take a look at how we can test these methods using unit tests. And then last but not least, we will implement the rest in the front end. All right, so taking a look at this create account function, again, we assume that we get a username and a description for user. What we have to do is, once we get the user, the hash of that username, what we want to do is we want to create a new user object in our users mapping, right? So what we do here is we will basically go ahead and say users, and then username hash. This is the one that we've created earlier. And then we can say, okay, so the creation date of that is now, which is like a global keyword, and solidity, which is the current time, basically. And then we can say, okay, we want to update username hash owner, which is the message.sender, while message is like a global variable, if you will. This is the account that made the transaction. We want to say the username of that particular user that we create is the username that we get from the front end or whoever calls that function. And then, obviously, last but not least, we have a description. So the username hash, we put in here again, description, and then we have the description here. Pretty straightforward. And last but not least, now that we've created this user object, if you will, we need to kind of map that to our list of owners so that we know, okay, that particular user object belongs to this particular owner. So for that, we go here in our owners mapping, and we say, okay, so the message.sender is the owner of this username hash, if you will, which again is mapped to the user object eventually. So that's the create account function. Editing an account is also pretty straightforward. First thing what we want to do is we want to make sure that only the owner of an account can actually update that account. We do that with a require statement right there. And then what we can do first is updating the description in case one is given. This is, again, the same thing. So we say username hash here, dot description, and then we assign the description that's given. By the way, if I make any typos here or anything, shout at me. Live coding is hard, and you might earn a t-shirt for that. And then we have possibly a picture hash there. That is going to be an IPFS hash that we get when we uploaded an image to IPFS. What we want to do here is we want to make sure that we only really set that picture hash when we have one. So what we do is we check whether the length of the picture hash is actually there, it's not empty. I guess that's what I want to say. And only then we say we set that property in our user object to update it. So in this case, it's the picture property, and it gets the picture hash. Okay, there you go. Right, so now we can edit an account, and I hope I typed everything right here. User exists is a function that we obviously need in the front end to double check whether a given user already exists when we want to create a user, because we don't want to create a user twice. For that, we just do a simple check. We see whether in the users mapping that we have, the given username hash actually has a creation date, right? And then what we do is we return that, and then we know whether this user exists or not. Cool. Now we have that, and then to the meat of the application, which is tweeting. We want to first here get our user. So we have a user, and we again fetch that from our mapping there. So we see users username hash. That's right there. And then what we do is we need to get a tweet index. So the reason why we need to do that is because eventually we want to say something like this. We want to say user.tweets, and then we give it the tweet index. And then this is going to be the tweet eventually, which gets tweet content, or the content in this case. So the tweet index is going to be whatever index we have in the tweets property of the user object. So we can basically say that tweet index is user tweets, and then length plus plus. That's going to be it, basically. All right. And last but not least, once we've done that, we emit a new tweet, which takes, and I can never remember, scroll up here. All right, it takes the hash, the tweet, and the time. So the username, hash, tweet, and time. Let's do that. Username, hash, and the content, and the time. All right. So with that in place, we now have all the methods implemented, and the next thing we do is we're going to write some unit tests for it, and then we make the app work.
So
Okay,
we were actually, we have a lot less time than we thought. I just found out. And we were supposed to have 45 minutes. Yes, question?
Sorry, which version is?
Sorry, say, can you speak a little bit louder? It's a really good point, and it's very, very astute of you to notice that. This is the first, finally, there's someone that noticed it. We actually, it's really not needed because we are using events. There's no need to store the tweet in the contract. You're exactly right. We're actually getting, we're getting free storage by using events. This was more to show that we can store the tweet in the contract, I guess. And you're right, it's not actually needed. Because we're subscribing to the events in the dApp, that's going to give us the tweet that we need to show in the UI. So very good observation. We actually have a lot less time than we thought. So we have a backup plan for this, thanks to Pascal. It's awesome commits. So what we're going to do is we've got the contract here. The next step was to write our unit tests, and then after that, code our dApp. So very quickly, I'm going to get Pascal to add a remote in, and we're just going to kind of time travel here. Just so you know what I'm doing, what we're doing here. So if you look at our start branch, if you look at our solutions branch here, and then look at our commits, where is it?
Click on code for that.
Am I not there?
Yeah.
There we are. So look, we have step 0, 1, 2, and 3. So Pascal is going to fast forward us to having these, I would just say probably step 3. And then we're basically going to time travel, code everything for us, and then we're just going to walk through the rest of the code really quickly, show you how it works.
Okay, cool. That's interesting. Had no idea we had. How much time do we actually have then?
I think, yeah, maybe 20 minutes.
Wow.
We're supposed to
Yeah,
have
that's like
45 or something.
half of the time that we thought. Okay. Well, no problem. We're prepared, obviously. Let's fix this. Let's see. I'm going to quit this one really quick. All right. So just that you know what we're doing, we're basically adding the solutions now. Sorry. All right. The cool thing about that is that you can do exactly the same. Like you can take a look at the repository, check out that branch, and then check out every single commit with all the changes that we've done. All right, so I'm going to check out the latest state, basically, I guess.
Yep.
So what you want?
Yep.
All right, having that, running Embark again.
Yep.
And all of a sudden, we have everything done.
See, that was pretty cool. We're that, here. We can code in 5 minutes. It's no big deal. All right, so very quickly, what we wanted to show, what we were going to go through and code together, were some unit tests. So we're going to unit test all the functions that Pascal ran us through. Just very quickly to show you what's happening. If you look up here, we've got a dTwitter object. This was code generated for us by Embark. it basically gives us access to all of our methods and our events that we're going to use in the actual dApp. This config is also kind of cool. We can configure small pieces and unit test them if we'd like, or change any config options we want, and even pass in different constructor parameters if we wanted to do that. And then there's just some overall setup for our unit tests, some variables there. But basically, you can see here, we're testing each one of the components. For this particular contract, which is we only have one contract, so we set up a contract block. We're going to test each of the components for our contract. So for this one, we're testing the create account. So you notice here, we've got the dTwitter object, and we're going to access the methods. So one of the methods that we created was the create account. So we pass in the username description, and because we're updating the contract state, we need to pay for it, so we need to send this transaction. Also, it is an asynchronous awaited method. So here we get a transaction receipt, and we just assert that that transaction receipt is actually true, the status was true, and that we actually had a successful transaction. The next thing is checking to see if that create account method actually added a user to our mapping. So we just basically go into our contract, we check that mapping, we hash our username, which is the test handle, we grab, so even though users is a mapping and not a method, it's just still accessed by, it kind of hangs off the methods object. And then because we're querying the contract, we're not actually paying for it, so we just need a .call at the end. Nothing kind of crazy there. And the same thing, there's an owner's mapping. We're going to check that that owner exists in the owner's mapping. It's very similar. It's dtwitter.methods.owners. We're using our default account, so that's basically the account that was used in the very first step when we called create user to actually, that's going to be our message.sender. Remember from when Pascal was describing the actual contract. So we're using this default account to check to see if the user exists in the owner's mapping. Then we do the users exist method. That's useful for us when we're actually typing in a username for the validation for creating account. Then we edit the account. Nothing crazy here. I'm going to kind of speed through. Then there's the tweet itself. So this is kind of how you subscribe to a contract event. So you just say dtwitter.events.new tweet. We can filter those events by the username hash. So that means if you remember looking at this contract, look up where a new tweet is specified. We've got this indexed property here from. So that's going to let us filter the events by a particular property. So we're filtering and saying, okay, we only want events for this particular user. So if you remember when I clicked on a particular user profile and we saw all these tweets come up, that's what this filter is doing. On top of that, we can filter using a block number. So by doing from block 1, it's going to get us all the tweets from the beginning of time on that chain. Okay, very quickly, once an event is triggered, we get this on data event, and that's when we're going to test our unit test. So I'm going to let Pascal very quickly jump through the actual, I don't know if you even want to do it.
I think more important would be to at least run the test so that people see that.
Yeah, that's a good idea. Yeah, we are not lying. Yeah, we're not liars. Okay, all right. So embark test. And my terminal is pretty awesome, so you got to kind of do this to see it.
So maybe what we can say really quick is that when you run embark test, which obviously is a command from embark, it does a couple of things for us, right? So it also compiles the smart contract, it deploys it for us, and then it runs the tests respectively. And as we can see here, everything's green, so that's wonderful.
You can pretend it's green.
Yeah, well, yeah. If you're colorblind, then it's always green, right? The last part that we unfortunately can't talk about it anymore because of missing time would basically be using exactly the same APIs that we've just seen in the tests, exactly the same APIs in the JavaScript front end. That was just JavaScript, right? So it's exactly the same stuff, and you just do the same thing in the browser. So you call dtwitter.methods.something, you call it, you get a transaction back, depending on what API call you do. But again, this stuff is up online on GitHub. We're also going to share the repository on Twitter. You could follow us there if you want to. Follow Embark or Status for updates. And make sure to come to our room.
Yeah, and also this is 3.2 features, which is we've already moved past that. Version 4 is going to be released at DevCon by Yuri. So make sure that those features blow everything out of the water we just showed you. So go to Yuri's talk. I forgot what day, but check it out. Version 4 is coming. Your mind's gonna be blown. Yeah. Cool. Good.
Thanks for your attention.
Thank you guys.
Sorry to cut you short, Ryan.
That's all right.
We were protected. It's okay.
Yeah. It's good.
So yeah, I mean, just to reiterate what Pascal and Eric said, Embark 4 is genuinely amazing. It comes with a whole bunch of stuff that is just not provided or anything even close to it by any other framework on Ethereum. So I really do recommend that you hang out at DevCon, look out for Yuri and that talk because it's going to be amazing. We've got a really, really exciting little interlude next before our next workshop. And that's my good friend Kevin Owocki, who's going to come up and tell us a little bit about contributing to open source and what it really means to build a sustainable movement in these software networks that we're working on. And Gitcoin is super involved with some of the prizes for crypto life. So without any further ado, Kev, blow minds.
Thanks, Andy. Hello. So, Andy, I have 10 minutes-ish, it sounds like. Okay, sounds good. So I'd like to start by saying thank you to Status for having us, and it's really amazing to be in this venue talking about all the amazing stuff that's happening in the ecosystem and seeing people build. Thank you to Embark for rolling with this. I know that the timing thing was an issue, so we'll just roll with it. So my name is Kevin Owocki. You may know me if you're in the Colorado scene as the organizer of the Boulder Blockchain Meetup. I am also a mesh member at Consensus and one of the spoke leads at Gitcoin, which is a project that is built to grow and maintain open source software. We are not a coin ourselves. We've never done an ICO. We are a place where you can get coins. So the basic use case is that you can put a bounty on any GitHub issue, and then when that GitHub issue is turned around by a coder from across the world, they'll be paid out in Ether or any ERC20 tokens. So it's basically a double-sided market for growing and sustaining open source software, and also for pushing Web3 forward. We've done about 2,000 bounties on the platform since it launched at the end of last year, and have also found over a dozen people full-time work in the space. So super excited to see people contributing to the ecosystem through Gitcoin, and then coming to work on crypto full-time after they've sort of stuck their toes in the water. Our mission is to grow and sustain open source software. I just actually flew in this morning. Yesterday I was at the Sustain OSS Summit, which was in London. It was a group of about 80 or 90 people who are passionate about sustaining open source software. And the sort of credo is that open source software is manna from the heavens. It's created billions of dollars a year in economic value, but the people who are working on it are too often working on open source software nights and weekends, and they're creating a lot of value for the world, and they're not capturing a lot of that value. And so part of the reason why I started Gitcoin was that I've been doing tech stuff for like 20 years, and everything I've done has been based off of open source software. So trying to find a way to align incentives using blockchain technology between contributors and their users. One of the things that's been neat about doing 2,000 bounties on Gitcoin is that we're building a peer-to-peer network of jobs. I've been giving a talk called Mesh Network of Jobs. And so as opposed to a traditional corporation where you've got a one-to-many relationship between employees and the corporation, what Gitcoin's network, and this is actually real data that I coded up in d3.js from Gitcoin's network, we're building a mesh network of jobs. So there's a one-to-many relationship, or sorry, a many-to-many relationship in a mesh network of jobs between contributors and the people who are paying them. So it sort of creates a different dynamic between the funder and the contributor, and we're sort of, well, not to be self-important, but we think that we're trying to create a jobs-based ecosystem on the blockchain. And so if you think that we're building an open source financial system, of course there's going to be speculative apps that are going to exist out there. There's going to be censorship resistant apps, but we think that there's going to be a whole new category of jobs-based apps, and Gitcoin would like to be one of the projects that's trailblazing there. So that's our mesh network. This is sort of a broader view of that mesh network and the 2,000 connections that we've created. This is a graph of all the connections we've created. Each node in the network is a person in the network, and each edge is a bounty that's been done between two nodes in the network. So you notice some of the top projects in the space are in our network. We've got MetaMask, the Ethereum Foundation, Status, and I would be remiss if I didn't mention that Embark has some bounties up there. So all of y'all who just saw that great presentation by the Embark maintainers, come do some Embark bounties on Gitcoin. One thing that's neat about building a jobs network on Ethereum is that each person in the network is their own unique person from across the world, and I like to remember that that people have different biases and different backgrounds than me, especially since I'm a sort of like a middle-class white guy from the United States. People just have different experiences and ways that they approach problems, and that's what I'm here to talk to y'all about today. So basically, we've built this mesh network of jobs that is very focused on extrinsic motivation. So if you get paid for a task, that's a very good example of extrinsic motivation. And what we've learned over time is that people do tasks not only for extrinsic reasons, but also for intrinsic reasons. We think that the triangle of jobs, the reasons why people do work on Gitcoin is because they want to get compensated well, but they also want to do work that aligns with their values and has impact. So they want to do work that has impact on the ecosystem, that has impact on their skill sets, and has impact on their relationships. And that's what I'm here to talk about today. We're launching a new product called Kudos, which is a way to show appreciation and build relationships that pairs the extrinsic motivation that currently exists on Gitcoin with the intrinsic motivation that you would have, say, if you were out celebrating a new release or a milestone in your project. We think that teams that are physically located together in the traditional jobs world will go out and celebrate at a bar or at a restaurant when they have a milestone. We want to unbundle jobs, and so the relationships that are being built on Gitcoin we think are one of the most important tangible assets that we're building. And so what Kudos is it's a non-fungible token that allows you to send a compliment for the price of a postage stamp on top of your bounty. So basically, the average bounty on Gitcoin is $170. For the price of a postage stamp, which in the US is about 45 cents, you can send a compliment, like, so basically something that someone can display proudly on their profile, and it's a non-fungible token that's got some beautiful art that's associated with it that represents their skill set. So we're sort of bootstrapping reputation on the platform by doing this. For example, if you know someone whose contributions are magical, then you should send them this magical unicorn Kudos. Or if you know someone who is a force when it comes to Linux, why not send them this Linux wizard Kudos? If you know someone who is a genius that brings new ideas to life and activates creative thinking and marries left brain and right brain, then why not send them this genius Kudos? This one's just for fun. I had to throw an Office Space reference into the Kudos marketplace. I don't know why you'd send someone a red stapler unless it was a meme. And then this one's my favorite just because it's weird and creepy. This is a Kudos that celebrates Vitalik's leadership in the Ethereum world, and one day maybe he'll discover it and either think I'm weird or tweet about it. So that's Kudos. It's new. It's launching at DevCon and at Status. I am very pleased to say that we have created these trophies for the winners of the Status Crypto Life Hackathon, and this is what they look like. They're basically just a physical collectible that commemorates a great job that you've done on any of the various tracks at the Crypto Life Hackathon. At the bottom of the trophy, there is a QR code, so you scan that, and then you redeem the non-fungible token at the end of the hackathon. So that's our announcement. That's Gitcoin. Thank you very much to Andy and to Status for having us, and look forward to hanging out with y'all this weekend at the Status Hackathon and also at DevCon. Thank you very much. Thanks, man.
All right. I think it's obvious why Kev is one of my more favorite people in the world. Thank you so much for those trophies, man. Those are going to be amazing to hand out. And they also will be linked, obviously, to stuff in your Status wallets, because we can do that. And it's all part of what bringing crypto closer to life really means. So we're moving swiftly into the next session, still somehow on time, which is really quite rare and pretty awesome. It's another tough decision, right? So we've got Mariano from MakerDAO in here. I really highly recommend staying for this talk. We're going to be talking about like some of the tools used to develop DAppHub. Maker is obviously like the authors of DAI and that whole thing that has kicked off the stablecoin revolution. It's amazing what they've done. So Mariana's going to be going over that. We've got Shruti up here from Consensus in the hall next door. She's going to be talking about token engineering and analysis at Consensus. And then Jose from MyBits in the Embark room, and he's going to be talking about creating financial dApps in record time. So without any further ado, Mariana from MakerDAO. Woo!
Hey guys, how's it going? Oh, I'm a little out of breath. I had to run and buy this cable, otherwise I couldn't have been able to give the presentation, so let's hope that it works. Yeah. Thank you. Okay, so hi everybody. My name is Mariano Conti. I'm from MakerDAO. I'm the head of Oracles and backend services. And today, like 95% of my talk is going to be here in the command line. I'm going to show you the tools that we use to build and test our smart contracts and also interact with the blockchain all through the command line, all through two tools that we call Seth and Dapp. And I am going to go into here just to show you where you can download them. This is dapp.tools. And we've been working on these tools at DAppHub for over 2 years now, mostly something like 3 years. And we have a simple one-line installer, but this currently will not work for Macs just because we use the Nix package manager behind the scenes, and it's been lately updated and does some weird things with Mac. So we have a manual method for installation that's a little bit tricky, but if you want to check it out, it's dapp.tools. And without further ado, I'm just going to start typing some commands into the terminal. So our main tool that we use is called Seth. And Seth is like a Swiss Army knife for the blockchain. we can do everything with it. Let's start with some simple commands. We can convert numbers to way. We can say 1 ether, that's perfect. Everything here uses like the Unix philosophy, so we can pipe stuff around. We can say 1 ether, and we can pipe it to UN256. We can get the number that this is something that the EVM understands. That's like 1 ether in UN256. The main thing that this does is call and send methods to the blockchain, right? So there's 2 ways to do this. Either we can have a node running, or we can use an Infura node maybe, or whichever node you want. So in this case, I do not have a node running, so I can export some variables. I can say Seth chain equals ETH live, and that automatically tells my environment that I want to use the Infura API to interact with the blockchain. So if I start typing some commands, I can type Seth chain and look and see that I'm running the ETH live chain. And I can query the latest block maybe. And of course, I get a whole bunch of information. I can just query the number. This is the current number. I can just, let's say, I don't know, the latest timestamp. And of course, that's pretty current. I can go date. And yeah, we can see that it's like 25 seconds away. So what else can we do with this? This tool is amazing in that it does not need a node to sign transactions. So behind the scenes, it uses another tool that we have called ETH sign, which is basically a packed, the Go libraries from Geth. We pack them into a little program that allows you to sign transactions and sign messages. So even if you are running a local node, it will by default not use the accounts in your node. This is for extra security. So the only downside is that you have to run your own nonce management, but we think that's kind of a non-issue. So if I go Seth accounts, I can see that I have a whole bunch of accounts locally, and I can type Seth ls, and this will give me the balance of each of these accounts. Now let's start trying something. Let's say let's go to Etherscan and find the maker token. And this is the address. So I can export mkr equals this address. So now it starts getting interesting. Seth call is our most popular command. I can call into the maker contract and say, okay, let's say total supply. This gives me back the number in UN256, right? So I can also give it a hint as to, well, in this case, it's not going to do a lot, but what to expect the return value to be. And of course, I can start piping that. This is a numbering way, so I can say, for example, I can put it to decimal, and then I can pipe it from way, and I get 1 million MKR tokens, which is, of course, the total number of MKR available. You can do almost everything that you can do in like a UI environment, you can do here with Seth, as long as you know the correct ABIs. So you can call balance off. We pass in an address, and we know that it returns a UN256. And let's go to maybe the latest. Let's see how much the Bitfinex wallet maybe has. And of course, we can pipe it down. Okay, so it's not that much, 976 MKR. This is gonna come in nicely later when we discuss MKR volumes. But In addition, I'm going to now move to the Koban blockchain so we can play with this a little bit. I can say export Seth chain equals Koban. And now, if I run the latest timestamp, well, let's go with the latest number. You're going to see that it's in the 9 million. Yeah. So now I'm working strictly in the Koban test chain. I can see that I have other different accounts. And let's try to send a transaction, right? So I'm going to go Seth send. And let's send maybe to this address a value. And this is where the Unix philosophy starts coming in. I can say Seth to weigh, let's go 1 ether from, let's say, maybe this account. And I can specify whatever parameters I want, right? Like gas, 21,000, price. I have no idea what the current price is, but I can probably say Seth to weigh 5 giveaway. And this is going to ask me for my passphrase. And this is going to be quick probably because this is Koban. And this is the hash. So I can, of course, inspect this. I can say Seth receipt of the hash. I get everything back. I can say, OK, how much gas was used? This is, of course, just sending simple leaf. So it's 21,000. And so this is the gist of it. I'm going to show you a couple more commands, but I now want to move on to the second tool that we built, which is DApp. And DApp is a tool that we use as a way to create smart contracts, as a package manager, as a testing tool, and also as a deployer and verifier of code. So I'm going to create a new empty folder, and I'm going to say DApp init. What this really does, it only it creates like a template smart contract. Has nothing in it, just like the version of Solidity that I currently have. And it also creates a simple test. So this is using our DAppSys library for testing. So this is a status test that inherits from DS test. And we can start playing with this. I can say DApp test. It will clean, it will compile my stuff and say, OK, it passed 2 basic tests. And this behind the scenes is using another program we created called HEVM, which is a complete version of the Ethereum virtual machine built in Haskell. And Trail of Bits is using it for some other software. This is all either GPL3 or AGPL, so everything is open source. And OK, so let's try adding some stuff. We already have a lot of packages ourselves that we use, so I can say dapp install DS token. And this will go into GitHub and grab the latest code for our version of an ERC20 token, which is the DS token. This is the library we use for DAI, for MKR. And let's go into the code a little bit, just so I can show you. And let's increase this. Not so much. Yeah. So I can say import DS token. This is all very basic. And let's see if this works. I can say that build. So far, so good. We're running with SolC version 0.4.24, right? But the cool thing about this is, since we're using Nix on the back end, we have a whole bunch of libraries available to us. So I can change the pragma to SolC 0.25. I can try to build this, and it's going to give me an error because I'm trying to compile with SolC 0.4.24, and this is now available. So what we can use is we have a subcommand inside DApp that says use, and we can pass any version of Solidity that we want. In this case, it's 0.25. It's going to look for it in my computer, and if it doesn't find it, it's going to go out into Nix packages and it's going to get it. So I just run this with, if I try 0.23 that I do not have it installed, and I'm not going to wait for this here, but it's downloading the whole of Sol-C, and since it already had most of the packages, now it's compiling Sol-C 0.4.23, and it's going to take a long time, so I'm not going to do it. But you essentially have every single Sol-C version available to you. And we're going to put those in a cache somewhere so you don't have to build them locally. So let's go back to this one. And I'm not exactly sure what I'm going to build here. I'm probably just going to do something stupid just to test. Let's say I have a, say balance equals 0. Let's do a simple function. Let's call it external. Oh, okay, right, I'm gonna put this back at 0.24. Hope this is not too boring. I told everybody this was gonna be like a straight up CLI, me talking for 45 minutes, but found that this is quite interesting and powerful. So I can go to the status tests, and let me say that, what do I call this? Increase. uint256x, say, equals 5, and let's do a result status that increased by x, and then we assert that, let me say that the balance is public. That status.balance, I'm going to say equals 0, and let's see what that does. No. Yeah, that's fine. I'm not returning anything from this, so let's start build and testing. So exactly what we expect, right? It's the wrong uint value. We expected a 0, as we said, but we actually got 5. And we can see that this uses also like source mapping to give us exactly the places where we got the errors. So I'm going to fix this and say that the balance after we increased 0 by 5 equals 5. Then we're not going to have any issues. And let's go one way further. Let's actually deploy this useless piece of Solidity code. We can say, after we dap build and dap test, we can call dap create. And we can say the contract name is status. So let's say dap create status sending, I don't know, 500,000 gas maybe. And of course, we don't have a from account. So let's try with this one. So we're going to send the transaction. And so far, so good. It's going to create a smart contract in Coven. And I'm going to look for it here. And I'm going to show you one of the most powerful things that we built recently that's been saving us a lot of time. If you look at the code, you can see that on Etherscan, you can verify and publish it, right? And they recently opened up their API. So we're going to do something. We're going to send out a different contract, but we're going to pass a verify flag. This is going to create a second contract. And behind the scenes, Sol-C has a very useful metadata function that I'm going to show it to you in the out folder. And you can see this is the meta output of the Solidity code. So it tells you the compiler version, the ABI, what settings were used, everything. So this is essentially all we need, plus the source code, right, to verify this. So if I look at the second contract that I just created 36 seconds ago, you can see that the code is already verified. So I'm going to show you what happened here. It created the transaction, and then since I passed the verify flag, it just says, okay, I'm going to verify the contract on Etherscan. I check what's the current chain I'm in. In this case, it's Coven. So it goes to the Coven API. You need to have an Etherscan API key. I'm not going to show mine here, but I have mine exported like this. And if you don't have it, it'll just complain. But essentially, every single contract that you create, you verify it instantly, and you can see that this is the status contract. It's not, optimizations were not enabled. This is the compiler version that I'm using. You can see that the first line is verified using DAppTools. And we can even try this with something probably a little bit more complex, like a DS value. I'm going to change this code a little bit just so it's not verified. So I'm going to say this is probably something that's not in there. I'm going to build this. I'm going to dap create a DS value passing, let's say, 2 million gas from, I don't remember the account. Oh, I can say export ETH from equals, like this is, everything is documented in DAppTools, so you can probably look at this. So I don't even have to pass from parameter anymore. In fact, I don't even, if I know that I'm going to be using the same gas, I'm going to export everything and then just create a DS value with everything here. I can also do the same with the password, but I'm not going to show that just yet. So I'm going to create a new one. I'm going to see that the code is there and it's unverified, possibly. So this is the code, so far so good. Now, I can also verify a contract that I've already deployed, of course. So I can verify contract, what is this? This is the name of the contract, the DS value, and I just pass the address of the contract. And this goes to the Etherscan API, and it tries a few times because it's sometimes a little bit slow and we don't want to. Oh, there you see pass verified. And I can see that this is a DS value with the correct optimization. And I don't know if this will work, but I'm going to compile once more with optimizations on, optimized. And I'm going to say dap use, I'm going to use the latest version, 25. I'm going to build with optimizations on. Yeah. Optimized. What is this? Optimize. Okay. Sorry about that. I do this all the time. Optimize. And I'm going to create a new one. And let's hope that we can see the new version. And after this, I'm just going to show a couple of things, how we interact with the die system and how we create a lot of our command line tools that we use every day. Because this is like still a little bit low level. So let me see if I can verify contracts. DS value, this one. Let me check that it was not verified before. Yeah. And let's give it a second, because I'm probably spamming the API today. And yeah, this saves us really an immense amount of time, because if you need to grab, also if your smart contracts like extend from many different files and you need to flatten them, and then you need to find out which version of the compiler you used. The good thing about Etherscan is that now it doesn't ask you for example, like parameters for the constructor. But still, this is like a very cool way to interact with this. So that's it for Seth and DApp. I just want to show you HEVM a little bit before I interact with the die system. So HEVM is the, like I said, let me see if I have tests on this value. Yeah. HEVM is our version of the EVM that runs using Haskell. And we can debug. We have an interactive debugger. I can say out value. No, it's not this one. It's the one with tests. And we have all of our unit tests here. Let's say I want to test this one. And I'm going to put this a little bit smaller so we can see everything. So in this case, we're looking at the bytecode for the contract on the top left. We have the source code in Solidity. And just going to start with the letter N to go from instruction to instruction. And let me go previous. So these were the first pushes, 80, 40, then it stores. And you can see that this is all in real time. It's showing exactly what the instructions are doing and how the code is reacting. We have the stack at the top, the gas, and I can step over. So this is just running the constructor. That's the setup function, creating a new DS value, a new test user. I'm skipping over a lot of stuff, setup, and then this is the test, right? So going next, next, next. And we can test every single instruction here. We already have a version almost ready for Constantinople with the new opcodes. And this is extremely useful. I basically had never gone into the EVM before this. Like, I knew Solidity, and then a lot of stuff was magic to me. But once you start looking and see what in each instruction really does, it becomes, I'm not going to say simple, but stops being magic anymore. It becomes something that you can understand. And hopefully we will understand, because the talks at DEF CON are usually pretty low level. So knowing a little bit of this will go a long way. So this is probably the last I'm going to show of EVM. But needless to say, it really makes our life easier, also with the formal verification and testing bytecode. We have people in Maker that they straight up program using bytecode instructions now, and they're very easy to debug with this. So that's the third one that I showed, which is HEVM. And now I'm just going to take like 5-10 minutes to show a little bit of the die system, how we call it from Seth. So this is the current version of die. This is the main contract called the tub. And as you can see, we like our 3-letter variables. And let's try to find, I'm gonna open MetaMask just a little bit so that I can go into a DAI dashboard and extract some data. And oh, looks like we're past 66 million DAI. That's very cool. So this is the tub address. I'm going to export again Seth chain. Actually, I'm gonna try it very quick to see if this works, but I'm going to run a light node, but I mean, I don't know if it's gonna sync up properly, so I will start using Infura, and then if I see that this works. So let's export the tub as this contract and start calling a couple of functions. So I'm gonna go to the definition and see, okay, so for example, this is the reference price feed, right, the pip. So this is the price of Ether in USD according to our oracles. So I can call the tub and say, okay, give me the pip, which is an address. And it's gonna return. Great, this is I can probably pipe this to Seth to address. And it gives me like a nice checksum version. So let's export this as like ETH USD. And we can call this is our main oracle, ETH USD oracle that's running live on mainnet. So I can call ETH USD, and let's say I want to peek the value, and I know that it returns a bytes 32 and a Boolean. So let's see what we get. Okay, it's perfect. The oracle is returning true. This means that it's working, and actually I'm gonna call read, which only returns the value. And I'm gonna pipe this, as I've shown before, to decimal, and then I'm gonna call from way. And okay, so looks like this is the current price of Ether coming straight from the blockchain, from our oracles. This is really cool because a lot of people use them. It's not just us. I don't know if I can name the companies, but this has been running for like way over a year, and it's pretty accurate. So we can do exactly the same thing for the MKR value. That's the PEP. So I'm just gonna go up here, and instead of calling the pip, I will call the PEP. And instead of reading from that one, I'm gonna read from this one. And what did I do? Oh, yeah, I'm missing a space here. And that's the price of MKR in USD at this very moment. And I know that this is, our smart contracts are a little bit hard to read, but almost everything is here. We can say, let's see, we have the cap, that's the debt ceiling, which originally it was 50 million DAI, and then we increased to 100. So we can call the cap, and it returns a UN256, and as always, we do the original creator, Seth, had a lot of commands that made stuff easier. It was like, with one command, you would convert to decimal, and then from way or to way, and we actually tried to add more of these commands, and the creator removed them. He said, like, no, Seth is a learning tool. It's like, you start using it, you get to see how Ethereum works. Like, you need to figure out why a UN256 is what it is, what is a way, and this is what really helped me, like, almost 3 years ago to get into blockchain development and Solidity and Ethereum. And even though I do have a couple of methods that make my life easier now, I still, like, for purposes of showing this stuff, I still like to do this. And as you can see, this is, hopefully, 100, 1, 2, 3, 4, 5, 6. 100 million. And yeah, I think I'm gonna stop here because this is a pretty heavy talk. Like, I know that this was all CLI comments and everything, but I'm gonna take like a couple of minutes of questions, and otherwise I'll just say thank you very much. And my name is Mariano Conti, and this is my Twitter if you wanna like chat about this or about anything. So thank you very much. Any questions? Yes. So the question was, in addition to having the EVM in Haskell, if we want to implement like a full node in Haskell, I know that there has been some talk about it, but it's really, even doing the HEVM, and I didn't participate in creating it, it was like a huge endeavor. So at the moment, we do not have any plans for that, just because maintaining another node implementation would be like extremely difficult. But it's not a bad idea. I mean, it's something that we could put out to the community in general, and I know that the Ethereum Foundation, they happily, if they see that there's a cool project that can implement a node in a different language, that they will almost definitely throw money at it. So, and HEVM is of course AGPL3, so anybody can take it and do their own thing. But that's a good idea. Any other questions? Yeah. Yeah, that comes out a lot. And we have people that are very critical of it. So the DAI credit system, some people call it like a decentralized bank on Ethereum. So you can give it your ETH and you can take out a loan. But we don't like talking about banks, and we don't like talking about loans, and we don't like talking about interest rates, because they mean very specific things in the real world. So back when the project was started, and this was before I actually joined, it was decided that a lot of the things that we say don't mean what we think they mean in the context of the blockchain and in the context of DAI and Maker. So the idea was to come up with new memes that we know mean exactly what they mean. It's like, I do not say that a CDP has debt. Like in the code, it is art. And the collateral is not collateral, it's ink, and you draw from it. And so we came up with this naming system that it takes a while to master and to really grasp. But once you do, and you talk to somebody else about it, you unequivocally know what you're talking about. And we know that this has been a barrier for a lot of people to like interact with our contracts. But we also think that we're changing a little bit how, think about like mint and burn. I know that they're used in the ecosystem, but we pushed that so hard, like 2 years ago, that now you see it everywhere, and they're like 4-letter words, right? And you know exactly what they mean, but that's maybe a bad example because it is probably used, but that was the reasoning behind it. Yeah. Yes? Oh man, I don't want to open my chat here, just because there may be sensitive stuff. But I'm gonna show you down there people talking about, hey, do you want to poke the pip because the art is down and the pep is out? And yeah, no. We have those conversations, and once you know, it's like a totally different language, but it's amazing. Yeah, we actually talk like that. Yeah, actually, the verifying on Etherscan, I wrote that last week, and I think I built it. Let me see, where is this? Verify. Verify. Yeah. So it's pretty simple. And in this case, yeah, it's using the Etherscan API. I grab a lot of stuff from the metadata and just send the API out. But yeah, I don't think I found the post method for Block Scout. But if there is, that can probably be my hack for the status hackathon. So I'm gonna ask you about it like in a minute. Okay, I think we're good. Yeah, thank you.
Thanks so much for everything, man.
No, thank you.
All right, so we've got 5 minutes, in which case we'll just take a short break if you need like the loo or you want to grab some food. Honestly, Mariano, that debugging stuff and the KEVM and the work that you guys have been doing, it's mind-boggling. Like to be able to step through the opcodes like that, I know that like it's not something you get to show often. That stuff is so cool already. Like it's unbelievable to see those tools coming out. I mean, from those ETH Prize interviews that we did, one of the #1 pain points is being able to debug my contracts properly, and it just like amazing work, man, really. Yeah. But we appreciate it, and we hope that like this event is the kind of place where like that kind of stuff is appreciated, because it's very, very cool to see that stuff, man. And to be able to step through and have code highlighting as I see like what stack is, like what's happening on the stack, it's so amazing. All right, so in 5 minutes, we will have Calvin Fichte in here doing Plasma 101 from Amisa Go. I highly recommend staying for that talk. It's going to be amazing. Plasma is the future. Plasma Cash for everything. Whoop, whoop. Then we've got Matt Garnet in the room next door from Bounties.network talking about building people in open source. And we'll have Ethan from MakerDAO doing another presentation, this time on using DAI.js, which is a really, really cool thing to do during a hackathon. And I've been in a number of ETH global hackathons where people have won using that particular library. So I recommend that one too. We'll start at 3 o'clock with Calvin though. So like 3 or 4 minute break, and I'll see if we can get some more people in here.